This is Pre-Calculus 12, Chapter 5.5. We're going to be looking at the laws of logarithms. These laws mirror the exponential laws, but recall that the logs are exponents. A slide rule is a visual representation of logs. So we slide this around and we multiply numbers. Here we're lined up with 1.5. So log 1.5. And we're lining up one here, and we're lining up one down here. So this is 1.5 times 2. And then we read up here for our answer, log 3. A slide rule is in scientific notation, so really this could also be log 15 plus log 2, which would give us log 30. So that's an example of multiplying. Here's an example of dividing. We use the numbers slightly differently. So we're going to do a number here, log 40 minus log 8. And that gives us our answer over here, log 5. Now, if you want to practice with a slide rule yourself, you can go to my website. And on my website, you'll find a link to this slide rule. And then you can just slide it around and practice. And what you'll notice, if you have a higher resolution, it's fine. These are our values. This is the log base 10 values. So if we look at 4, the log is about 0.62, between 6.1 and 6.2. We can also use the guide here. If we look at the A scale, this is the squared scale. And we can use this to take the square root. So because we're taking the square root here, this is actually the log value halved. So if we look at log 25, we get 5. And this is the cube scale. And you can see that this is repeated 3 times. When we do cube root, we take the third. So these are 1/3 the scale of this. It goes from 1 to 10, and then 10 to 100, and 100 to 1,000. If we wanted the cube root of 60, we would see that it's roughly 3.5678 3.92. If we use this on a calculator, we do the cube root of 60, we see that's 3.91. So it's right between 3.91 and 92. Okay, let's look at some other log laws. So recall that if we're multiplying powers, 2 to the power of 4 times 2 to the power of 5, we add the exponents, we get 2 to the power of 9. Log 2 to the power of 4 plus log 2 to the power of 5, we get log 2 to the power of 9. And if we just have values here, log 4 plus log 8 equals log 32. And in our most general form, log base a of x plus log base a of y equals log base a of x times y. And we have easy forms here. If you're just going to use the common log, we have log x plus log y equals log xy. If we're doing division, log 3 to the power of 7 minus log 3 to the power of 4 equals log 3 to the power of 3. So with the power laws, we would just subtract the exponents. And here, if we have log 28 minus log 7, that equals log 4. And the most general form, log a of x minus log a of y equals log a of bracket x divided by y bracket. And again, our general form would be log x minus log y equals log x divided by y. And for the power of a power law, we multiply the exponents, log 5 to the power of 2 to the power of 4, and we can just bring the exponent out front. 4 log 5 to the power of 2. If you're going to leave out brackets, log takes one term. So for instance, if I did log 2 plus 4, the brackets actually go here. If you actually wanted to take the log of 2 plus 4, then you'd have to put the brackets around the whole thing. Okay, and if we had a simpler example, log 6 to the power of 3, this equals 3 log 6. So our general formula is log base a of x to the power of k equals k log a x. These are all times, and this is x is the parameter. And in our most easy form, log x to the power of k equals k log x. This is k times log of x. Okay, and when you're using log laws, they require the same base in order to be able to use them. Okay, let's look at some examples of problems. So we have to simplify. That means to make one log and not to have any powers. Okay, so we have log 15 times 2 to the power of 2, and this is all one parameter. So this is log 15 times 4. The brackets are not necessary, but they're there to make it clearer. So we multiply 15 times 4, we get log 60. Log 72 minus log 3 to the power of 2 plus log 7. Everything we subtract goes into the denominator. Everything we add goes into the numerator. Log 72, 3 to the power of 2 is 9. And 7 goes into the numerator. Rather than multiplying, you can use mental math and do division first. Cancel, cancel. 72 divided by 9 is 8. So now we have log of 8 times 7. That's 56. Okay, any coefficients out front, we bring those in as powers. And again, minus goes in the denominator, plus goes in the numerator. Log 4 to the power of 3 times 5, and the 8 goes in the denominator. 4 to the power of 3 is 64 times 5 divided by 8. Again, we will cancel before we multiply. That makes it easier to do in our head. 64 divided by 8 is 8. Now we have log 8 times 5, that's just 40. We have other problems where we say expand. Okay, so we need a log for A, a log for B, and a log for C. So we're doing log A cubed. B is in the denominator, so log B squared. C is in the denominator. This is log C, And when we're taking square root, the power is a half. Now we take all the exponents and move them out front as coefficients. So 3 log A minus 2 log B minus 1/2 log C. Okay, it's best to use fractions rather than decimals. Fractions imply exact values. Okay, if we have just numbers, then we have to do prime factorization. 40 is 8 times 5. So that means we're adding logs and we're subtracting log square root 7. 7's a prime factor, 5's a prime factor, 8 is not a prime factor. And the prime factor of 8 is 2 and the exponent is 3. So log 2 to the power of 3 plus log 5 minus log 7, and again square root is power of a half. And then we bring the coefficients out front. 3 log 2 plus log 5 minus 1/2 log 7. So here's a couple extra logarithm laws. Log base A of A equals 1. Log base A of A to the power of x is equal to x. And recall in our last section, log base B of 1 equals 0. And that's for all b greater than 0, provided that b does not equal 1. Another useful logarithmic law is change of base. So if we want to change log base A of x to log base B of x, we have to use this formula. Log base B of x is going to be equal to log base A of x divided by log base A of B. And A, B, and x have to be greater than 0, and A and B cannot be equal to 1. And the easier form is if we want to change log x into log base B of x, we just do log base B of x equals log x of log B. And for a slightly harder problem, we need to estimate the log with given values. So if we're given log 4 is approximately 0.6 and log 13 is approximately 1.1, determine the log of 270,400 without a calculator. So we need to factorize this using these factors. But before we factor, we need to remove powers of 10. So log 270,400 equals log 2,704 plus log 100. And we want to factor out the powers of 10 because we can do this without a calculator. Now we need to do a factorization of this. We're only going to be dividing by 4 and 13 because those are the ones that we're given. And those should be the only factors of this number. Otherwise, we wouldn't have a proper problem. So 4, it's easier to divide by 4, so I'm going to do that. 2,704 goes into 6 times 24. Subtract, we get 3. Bring down the 0, 30, 7, 28. Subtract, we get 2. Bring down the 4, 24, that's 6. This is still even, so that means we can still divide by 4. 4 into 6, 7, 6. 1, that's 4. Subtract, that's 2. Bring down the 7. 27, 4 goes in 6 times, that's 24. Subtract, we have 3. Bring down the 6. 36, that's 9. This is no longer even. That means we need to divide by 13. That's the other factor. That goes in once, 13. Subtract, we get 3. Bring down the 9. 13 into 39, that goes 3 times. And we get 0. So we've divided by 4 twice. We've divided by 13 twice. This means we have log 4 squared plus log 13 squared plus log 100. That's just 2. Bring the exponents out front. We have 2 log 4 plus 2 log 13 plus 2. Now we can substitute our approximations. Now we can substitute our given values. This is 2 times 0.6 plus 2 times 1.1 plus 2. This gives us 1.2 plus 2.2 plus 2. And add that up, we get 5.4. And that's approximate. So again, it's important to factor out powers of 10 first. Because if we divided this by 4, we'd get 25, and we're not given a value for log 5. And then you're going to hit a dead end. And that completes this lesson.